Great, so welcome back to grade 7 math. We're now looking at adding fractions that are greater than 1. So we have two examples here. I have 1 and 2/5 plus 4 and 2/3. An example of this might be I'm at the end of the party and I have 1 2/5 liters pitchers of punch. And then in the other room, I still have 4 and 2/3 pitchers of punch. And if I were to combine the two together, how much punch or how many pitchers of punch would I have left at the end of the party? Well, here's how we can solve it. It's pretty simple just by estimating. So I have 1 and a bit plus 4 and a bit. So which means my answer should be approximately well, it should be 5 and some bits. And this bits could be enough to make it approximately 6. So I should probably have between 5 and 6 pitchers of punch left over. The way we can solve this this problem is by looking at the fractions separate from our actual numbers. So what this really means is I know I have at least 1 pitcher and 4 more pitchers. So I know I have at least 5. Now if I combine the rest, might it make 6? We're not sure. But what we can do is we can combine these using the same rules that we have been doing before, which is looking for a common denominator. So we look at the fractions only. So I have 5 and I have 3, and I see that my common denominator for the two of them is 15. So I multiply this fraction by 3 over 3, and I multiply the second fraction by 5 over 5. And so I just rewrite each fraction in equivalent forms. So 1 and 2/5 is the same thing as 1 and 6/15. And 4 and 2/3 is the same as 4 and 10/15. Now notice that the whole numbers don't change. I don't multiply times any of the factors. It's really only the fraction parts that I've converted. Now these are equivalent fractions, which means these are exactly the same as before. They represent the same quantities. But now because the denominator is the same, now I can add them because the divisions are the same. So if I add these two, my complete pitchers would be 5, and my fraction parts would be 6/15 plus 10/15 makes 16/15. Now, if we notice, that's more than 1 complete pitcher. So let's just convert this part into a mixed fraction. So my 5 is still a 5, and now my 16/15, now becomes 1 and 1/15, because each pitcher has 15 parts to it. So I remove 15 from the 16 to make a full pitcher, and I'm left with that 1 left over. So 1 and 1/15 plus my original 5 pitchers makes a total of 6 and 1/15. In the second example here, I have 2 and 1/3 plus 1 1/2. And this could mean, another example could mean I have 2 and 1/3 chocolate bars and I'm adding 1 1/2 chocolate bars. A couple of other examples that you can come up with, any with fractions. I have a 2 1/3 cups of sugar and I add 1 1/2 cups of sugar. How many total cups of sugar do I have? Again, we can estimate. So my 2 whole cups plus my 1 whole cup will make 3 cups. And my fraction part might make it might make an extra cup. So it might be between 3 and 4 should be my answer, or maybe a little bit more than 4 if it goes over. So what we'll do is we'll just look at the fraction part separate. So I have 1/3 and 1/2, and I find the common denominator for that part only, and I leave the whole numbers as normal. So 2 1/3 and 1 1/2. Well, my common denominator for both is 6. So I multiply this fraction by 2 over 2 and this fraction by 3 over 3. And so I convert them. So 2 and 1/3 is the same thing as 2 and 2/6. Let's just fix that. And 1 1/2 is the same as 1 and 3/6. So remember, we didn't change any of the quantities. It's really the same thing, just with a common denominator. Now, if I add these two together, I add my whole numbers, or my whole chocolate bar. So 2 plus 1 is 3. And then my pieces, 2/6 plus 3/6 is 5/6. Now notice that my numerator is less than my denominator, which means it does not make a full pitcher or a full chocolate bar or a full cup or whatever it is my question is asking for. So there's no longer any need to convert this. Can we reduce it any further? There's no other common factors of 5 and 6 that will help it reduce. So my final answer in this case is 3 and 5/6. So review both of these examples, do the problems in the textbook in class, and then you should be okay with this one. So hopefully you understood this problem.